friends, we are going to discuss the subjects related to the electrical, electronics and instrumentation for the GATE 2018. Our main target is GATE 2018. Simple. Firstly, my name is Amardeep Srivastava. I am going to deliver some of the topics related to signals and system. First, we start. We have to know the syllabus requirement for the GATE. The syllabus which covers the GATE for the signals and systems are as follows. First, definitions and its classification. Different operations on signal, operations, that is the shifting operations, scaling operation, reversal operations, differentiation, integration and convolution operations. We will going to discuss it later. Then we will discuss about continuous time Fourier transform, basic system properties, that is static system, dynamic system, causal system, linear system, time variant or time invariant system in the further classes. And we will going to discuss about some of the transform, that is Laplace transform, Fourier transform, jet transform and sampling theorem. Simple. Now let's start with our basics of signals and system. That is, what is signal and what is a system? Let's consider a block. This box, you may call it a black box because it contains some information which we don't know about this. The characteristic of this block we don't know, but we know the signals which we are going to the input and the output which we are going to take. Let's assume this is the input terminal and this is the output terminal of the device. In the input terminal, if we are inputting x of t, let's assume the x of t is the input signal and y of t is the output signal. That is, this system is going to perform some of the operations on x of t to produce y of t. Simple. This system will do some of the action on x of t to produce y of t or to confer some change in y of t. That's why we are considering it as a system. Now we will discuss about the different operations on signal. Signal. What is signal? Signal is nothing but which contains some information is known as signal. First, we will discuss about time scaling property of signal. Properties, we are going to discuss about the different operations on signal. First is time scaling. Let x of t is the input and y of t is the output of a signal. Okay? Now, let's consider the x of t, the required signal is this. That is, x of t is this 0, 4 and t. Let's assume this is our input signal to the system. Now, if we have to perform the time scaling operations on y of t, let us consider y of t is equal to x into a of t. For a not equals to 0. A is the scaling factor. Let's take two cases. First case, when a is greater than 1 and a is less than 1. For a greater than 1 case, let us consider a system having y of 2t, that is x of t when it is transmitted through a system will result in y of 2t, that is a is greater than 1, that is a equals to 2. When a is greater than 1, then it will perform an operation known as time compression. Let's assume time will compress, that is the width of this signal will compress. This is the signal x of t, and if we are performing y of 2t, then the signal, the remaining signal will convert it into time will compress, that is the time will divided by 2. As we are taking the scaling factor at e equals to 2, that's why the remaining signal at the output terminal we will collect as 0 to 2 as y of t. It will be x of 2t, y of t. This is the time compression. And if we want to expand the time in the time domain, we have to take a should be less than 1. That is, if x of t is transmitted through a signal through a system, then we will get y of t in if y of t is equal to y x of half of t, that is it will be expanded by the factor of 2, that is a is equals to 1 by 2, and the remaining signal will pass through the system and it will give the expansion of that signal, which is in 0 to 8. That's okay. This is the time scaling property, and we are going to the further expansion or further properties of signals related to this. It's very simple. We will now discuss the other properties of this system. Signal, sorry. The other property is time shifting. Time shifting. Shifting is of two types. Either it will be left shifting or it will be right shifting. Let us take example of we have applied a signal x of t in a system. We will denote the system as this, and we are getting system output as y of t. We have to shift the signal from right shifting or left shifting in the given system. Then let us assume if we are inputting x of t and we are getting from this system is x of t plus minus k, that is a shifting factor. K is known as shifting factor. Shifting factor. If let's take it very lightly and very simply, at x of t plus k, take this equals to 0, that is t is equal to minus k. The factor, the x of t will come in advanced form. Means before its time we have taking as x of t, that is it will be advanced. Now if we are taking as x of t minus k and considering the input, considering the function inside is equals to 0, that is t is equal to k, this function will shift to k, that is it will be delayed function. Delayed function. Now let's take an example to understand the shifting property of the signal. Let us take example. We have x of t as the rectangular pulse function, rectangular pulse function having the width -1 to 4 in the time domain axis. We have to perform left shifting operation and right shifting operation on this input signal x of t. If we will take, we have to draw x of t plus 1, that is the time advanced property. Time advanced. Time is advanced. We will have to consider this. Now as the time will advance, but remember one thing, the width of this signal will remain constant, that is width of this signal will remain constant, that is it will be altered, it will not be altered by time shifting property. Remember these things. This is the bullet points you have to remember at any time, because GATE uses different concepts on these topics, these concepts. That is, if we shift a function, let's take a example. We are on the x-axis. We have to do nothing. We have to just shift this signal to this, that is left shifting, right shifting, but without altering the width. We don't have to change the width of that signal. Simple. Now, as the signal is -1 to 4, and if we have to shift, let's assume left shifting, left by 1, that is x of t plus 1. If we consider the input variables inside the function, t plus 1 equals to 0, that is t is equal to -1. That is, we have to shift this function at t is equal to -1. Then what we will get? We will get the remaining function as -1 position will go to the -2 position, and 4 will come to the 3. That is, and width, here width is what? 5. And what will be the width here? Same 5. So the width remain unaltered. Remember this term. Simple, as the same right shifting will also occur. Now we are going to discuss about a term known as amplitude shifting. What is amplitude shifting? Amplitude shifting is nothing but the DC addition in a signal. Let us example, x of t is a signal which when it is passes through a system, it will give y of t as a system function. If a DC term, let us assume y of t is equal to k plus x of t is the output of the system. The k is known as DC term which will shift either upward or downward. Let's take an example, considering the same function, the impulse function having the width, the rectangular impulse function having the width minus 3 say 2 to x of t and t. This is x of t. Let's take y of 2 t is equal to 1 plus x of t. 1 plus x of t, that is 1. Addition of these 1 will shift the signal into upward shifting. That is, if we draw y of t, then we will get from minus 3 to less 0, it's negative, it's 0, that is it will shift it upward to 1, magnitude will be 1, this will be 1, and from this its magnitude is 2, from minus 3 to minus 2 its magnitude is 2, and we will add one extra additional DC term to this system, it will shift up to 3. That is from the minus 3c to minus 3 to up to 2, it will give 3, and then again 0, that is 1 will be added, that is 1. This is called the DC shifting of this phenomenon, right? Now we will discuss about the fourth property, that is known as the time reversal property of the system. Time reversal. If x of t is a signal which will give y of t as an output, then y of t is equal to x of minus t, that is reversal. Reversal is nothing, it's just a folding will take place about y-axis. That is, let's consider this is the x of t signal, and if we are reversing this signal as x of minus t, then it will shift reverse along y-axis. It will give just the mirror image of y-axis, that is this. This is known as the shifting property. We have discussed about the different properties of signals, and in the next class we will discuss about some of the questions and some of the standard definitions and classification of the signals. That's it.